This is the adoption curve. Really quick, I wanted to mention that it basically is the S-curve of adoption of technology, digital technology. Obviously, these industries here are well advanced into the digital transition, but these ones here are the ones that are prime to develop into this new industry and this new market. And utilities, obviously, and energy is one of those in this spectrum. Moving forward, how is this affecting the energy industry? We see four major changes in the energy industry right now, or four major drivers. Climate change, or at least in North America, the abundance of shale gas sources, forecast of lower electric demand, and the evolving business model. And when we look at that, we see that in the wholesale market, there are three major areas that are affecting the industry. Fuel mix migration, we're moving from nuclear and coal into more gas and renewable. We see large entrance of renewable energy, and we see the development and changes in the competitive energy markets, particularly the ISOs, if we're talking in North America. And then when we look at the distribution side, we see distributed energy resources, entrance, distributed generation, microgrids, and transactive energy that we spoke of this morning. So we see those changes on the distribution area, and that's fairly new from what we had before and we had in the past. So what we're seeing moving forward is we see the energy industry is going to have a much more active distribution network. And that distribution network will have some key components. The distribution network that we see in the future is one that has to be a promoter and a facilitator of a communications platform, control platform, connectivity, and commerce platform. What we see in communications, obviously, connecting to AMI and smart meters, the development of the communication network, protocols around cybersecurity, and latency and cloud. When we look at around control, we see elements like frequency regulation, ballpark control, reliability, and asset and operations management. Looking into connectivity, how the distribution network would allow new devices to be connected to the network, microgrids, electric vehicle, distributed generation, et cetera. And then in commerce, how the distribution network or the grid company is going to allow the development of distribution commerce by allowing demand response, charging and discharging stations, peer-to-peer energy trading, and VPP aggregators. Now, when we look at how ABB is responding to these challenges and these changes, we have developed a new platform called ABB Ability. And what ABB Ability does, it basically creates a set of standard technologies that allow us to connect multiple devices, develop the analytical components, and facilitate the development and the connectivity of these devices to lower cost, and maximize profitability for our customers. So what we have with ABB Ability is, first of all, the opportunity and the ability to connect field devices and sensors that are being deployed today. So how do we connect to transformers, how we get more data from power plants, how we get more data from digital substations, how we get more data from circuit breakers and other devices on the field. How to automate the data gathering and the automation of these processes and systems, the enterprise solutions that need to be deployed to make better decisions, and then finally, delivering these kind of solutions on environments like the cloud for open access and intelligent decision support. Now, when we look at this kind of pyramid or triangle, there is one thing to be said about data. We are working on moving that data from being just passive data to convert it to information, to move it into intelligence, knowledge, and finally wisdom. We can only do that by collaborating across multiple silos within the organization, connecting multiple devices, enabling multiple protocols to be exchanged, and be able to develop analytical components based on elements like machine learning that can take that knowledge, develop new knowledge, develop heuristics, develop neural networks that can take it to the next level. And also, when we're looking at the data, we want to look at the 5 V's of the data. We want to look at what kind of volumes of data can we manage, what is the velocity of that data, how fast are we getting that information, What is the variety of the data? So for some of the transformer analysis that we're doing, we're taking data that comes from infrared devices, temperature devices, images, sound, voice, different kind of formatting of that data. The validation of that data to make sure that this is correct and that we have the data that is reliable. And then finally, what is the value of that data? So we're looking at this digitalization, this transition from all these different perspectives. And right here, this is one of those examples of distribution digitalization. So what we have in this chart is basically we have different components on the field that are connected both from the electrical as well as the information network perspective. So we can get control of the electrons, and we can also get control of the data that is flowing from those devices. And we are using that data connected to our Ability platform on the cloud, both public as well as private cloud, and the applications that are connected here to improve performance, improve reliability, lower cost, et cetera. This diagram is just an idea of the kind of platforms that we're deploying right now on site. Now let's look at two specific examples of what we have to show today. So one of the use cases is actually in Switzerland, in Geneva, and it's called the eBus example. So what this is called the eBus to grid flash charging electric buses. So in this case, ABB has worked with the Transportation Authority in Geneva. We work with our transportation division within ABB, developing the buses, developing the charging device, which is this one that we see, and developing the infrastructure to support the charging of that device. In addition to that, the software and the information technology devices that goes behind that. Now, what is particular about this? Well, first of all, the bus that was designed by ABB includes many leading technologies in terms of zero emissions, low cost, high performance, high availability type of standards. Second, these type of charging stations allow for the bus not to have any kind of overhead cables that are coming, which not only increases the cost of the development and deployment of these systems, but also is less environmental friendly because you have to bring the copper, the aluminum, and all the other pieces that come with it. So this one doesn't include that. And it allows us to, also the technology was developed to perform fast charging, meaning that while the bus is stopping to load or unload passengers, it's charging very fast within 15 seconds. And this allows for the bus to have more autonomy, to be able to drive longer distances without having to interact with the network. But it also gives us some predictability about the loads that we have to put on the system for this particular bus. Also, we deployed the technology that allows us to do the asset management. So there is a control center where the operators can see where the assets are and any kind of maintenance that needs to be performed. So this is a small diagram of the different activities that we have there. So obviously we have the fleet of buses. We have the bus operator using the software to manage the transmission and the transportation network for these devices. We also have the DSO, the distribution system operator, managing the distribution network, managing the charging stations. And in the cloud, we have developed the SCADA for the real-time control, the enterprise asset management to manage the assets, predict the maintenance of the asset, and take a proactive role in terms of managing the asset. The DMS system to manage the distribution network and make it self-healing. Optimization, the Durham solution, and the commercial operations to buy and sell power with the transmission system operator. So this is an all-encompassing application for the Geneva transportation system. The second example that we have is CenterPoint in Houston. CenterPoint is just a distribution company. It doesn't own any assets. It's just basically the distribution system operator. And we deploy our systems for the field devices, the communication network, all wireless, the advanced distribution management system, and the outage analytics to provide advanced analytical components and predictability. It's a self-healing technology system, meaning that the system takes real-time measurements, detects when there is a particular outage, restores the system by isolating the outage, and automatically dispatches a crew, taking into consideration work management applications and asset management applications. The system was thoroughly tested in the last Harvey interaction. After about 90% of people in Houston lost power, within 2 hours after the storm passed, roughly 50% of those people that were affected had the power restored, even without having to call the utility. So that was a great success story that tested the boundaries of the capabilities of the system. But the importance there was the ability for the operators to interact with the system, know exactly what was going on at every point in time, in real time with the system, having the system make the basic decisions in terms of isolation, in terms of disconnection of the system in certain parts, and automatically sending the crews to the optimal spots where they will be able to recover the most amount of people in terms of power recovery in the fastest amount of time. So all of that using artificial intelligence, machine learning language that was able to take the data points and act based on that information. So those are the two business cases. I know I went a little fast, but I wanted to be conscious of the time. And I think now we are good for questions. Apologies for going too fast, but we have a booth area here outside, and we'll be happy to answer any questions in more detail.
Yeah, thanks so much, Carlos. Just a couple questions here from our audience. How are big companies, first of all, like ABB or Siemens, envisioning their roles under this ongoing energy transfer? Startup companies.
By doing that, you get an option.
Sorry, I couldn't hear.
Oh, sorry, someone else was talking.
Yeah.
Okay, sorry. So how are big companies like ABB and competitors, Siemens, envisioning their roles under this ongoing energy transformation, along with startup companies that are kind of disrupting business?
So we see two key elements on that. That's a really good question. The first one is, I particularly don't see any difference between the big company like ABB, Siemens, GE versus the small disruptors. I think the key operating word here has to be collaboration. We need to be able to work in open standards, being able to facilitate connectivity and interoperability between different providers. But the bigger role that we see as providers in this kind of journey that, for example, New York is having, is for us to bring ideas to the table and to facilitate that transition. But then we need to work with other stakeholders like state regulators, utilities, and other energy service providers into adapting those technologies and doing that. What I show in the two business cases are projects that started as a pilot project and now is going into production. I think the industry needs to be ready to start moving from projects into bigger deployments and adoption of technology. This morning, many of the speakers talk about the need to move from projects into more advanced applications. I think that's where we are today.
Yeah, and just as kind of a last thought here, what is your play in the lifecycle management of distributed energy resources, specifically in the DERMS world?
So we have solutions in that area. We are partnering, to the previous question. So there are some disruptor companies that were able to do things faster and better than we would because of our size and because of our legacy applications. So, for example, in the case of DERMS, we saw that we were going to serve the industry better, not by trying to develop something that has been already developed, but partnering with somebody that had an established solution there, and being able to bring that into our ABB Ability platform and then make it available to the rest of our customers.
Yeah. Thanks so much, Carlos.
Okay.
Everyone, please find Carlos and
Thank you.
have
Thank you very much.
more conversations later.